Okay, so Newton's first law of motion says that an object at rest will remain at rest unless another object or person comes along and exerts force upon it to actually move. That's the first part of that law. The second law is that an object in motion, if it's already in motion, it will remain in motion unless another object, so let's just say it's in motion, it remains in motion in a straight line, okay? Doesn't change directions, doesn't accelerate, doesn't go faster, doesn't go slower. It just remains at a constant speed unless another object comes along and exerts a force on it. And when that happens, then it will accelerate or change directions or maybe change speeds. So that is that's all Newton's first law of motion. And that's kind of weird with the motion. We have to think about that. But one way that we often talk about that is with when we're in a car. And okay, that is a wonderful car, I know. So the object is in motion, right? And it gets into motion because of its engine, so that's a given, right? But let's say the object has to slam on its brakes for whatever reason. The person in the car, unless strapped to the car, will continue moving in the same direction, in the same motion. Unless, like I said, unless we've got a seatbelt on here, that person will keep going straight. And that's why, it's so important to wear your seatbelt, because then this person can hit the windshield or even go through the windshield. Also, objects in space, like asteroids and stuff like that, they don't just sit there in space. They actually are moving in a straight line, just continuously, unless they hit another asteroid. And then if they do hit this asteroid, then they will, let's put this asteroid more in front of him. If they hit that asteroid, they might, bounce off and change directions. So otherwise, objects in space will continue in motion at the same speed and the same direction. So the reason for that is on Earth, things don't just continue going on Earth. And that's because of the force of gravity. That is pulling all the objects down to the earth. The force of gravity, and horizontally, there's another force of friction. And that slows things down. You might have seen like Magic School Bus. They played baseball and they'd hit the ball and they couldn't stop at any of the bases. They were out of control. And we talked about this a lot in class at the beginning of the year. They just keep slipping all over the place. So if there were no friction, then you students would be in the hall just ricocheting off everybody, and there would be no way to actually stop. We also looked at like a space video where that was the case. A guy went out in space and tried to work on the space shuttle he was in, or the rocket, and he said it was like a major workout because he not only had to make this movement to try to push on the spaceship, but the spaceship, was pushing back on him. And he had to use all kinds of muscles to keep himself steady and stable. So that is Newton's first law of motion. Newton's second law of motion is force equals mass times acceleration. So this confused me for a while. I was like, oh, what are you talking about? But when we're talking about force, we're talking about force from another object with mass and acceleration. So when this force acts on an object, then it accelerates. So let's just say, I think we already said this, but we'll just say this is the force. And it's acting on an object. And this is an object with mass. And when it acts on this object is going to accelerate or change its position. Right? It changes its speed, or it changes its direction. So that's basically what we talked about at first, right? That's the second law of motion.